Very good morning, all. Am I audible? Please let me know whether the board is visible or not. Yes, I am requesting everyone, click the right side corner. In the right side corner, you can find 3 dots. Just to click that dot, there you can find the option is called quality. அதை click பண்ணி அதில் 720p fix பண்ணிக்கோங்க. Then only 720 or you can go to 1 minute 480, right? Otherwise board is not visible. Very good morning to everyone. Really very happy to see you all after a long time. So today we are going to start EMT. That is, EMT means electromagnetic field theory, right? See, the problem is, many of you, when I have shared the videos of EMTs, I don't know why you people are felt in difficulties, right? அது ஏன் உங்களுக்கு அந்த மாதிரி ஃபீல் ஆச்சு அப்படின்றது தெரியல. Anyway, let us start EMT by myself. Let me teach all those things one by one. And மற்ற சப்ஜெக்ட் எல்லாம் கம்பேர் பண்ணும்போது EMT வந்து there is nothing in EMT, right? Just we have to understand some basic rules. And if you are understanding all fundamental basics properly, then EMT will become very easy and you will be able to crack all questions, whatever it might be in interview or it might be in your exam, right? Okay, let me start. So electromagnetic field theory. Basically what we are going to learn in electromagnetic field theory. In circuit theory, already we learned some basics, like what kind of basics we know. We know the basic definition for current, we know what do you mean by charge, we know what do you mean by voltage, we know what do you mean by power, we know what do you mean by energy, right? That's all. There are no more things to learn in electrical circuits. So just we are learning some basics in electrical circuits, and then what we are doing, we are applying all those basics, whatever the knowledge that we are getting from the circuit theory, that things will be applied to all our practical applications, like our electrical machines, like our power system, right? See, subject wise they might be differentiated, but there is no difference between electrical machines, power system, circuit theory, signals and system. All subjects are, if you put them together after completing the whole syllabus, it will become just, you can take a single power system layout and you can connect electrical machines, you can pass some mechanical signal, it will be converted into electrical signal, and then we are transporting it. But during this entire journey, some quantities are invisible. Yes or no? In power system, we might have studied about capacitor, inductor modeling, like short transmission line modeling, medium transmission line modeling. Now in medium transmission line, there are many classification, nominal T model, nominal phi model. Why we are going up with all those things? While going each and every designing or modeling, we are considering different parameter, like admittance effect, capacitance effect, inductance effect, resistance effect. At some places we are not considering some person, at some places we are considering all persons. Like in long transmission modeling, we are considering all effect, like shunt resistance, like that is called conductance, right? So conductance effect, capacitance effect, inductance effect, resistance effect. But the thing is, the reality is, when we are going outside, there are some transmission lines are going, right? Everywhere you can see it, but is it visible to us? Can you see the effect of capacitance directly? Yes, this is called capacitor, this is called inductor. Can you say like that? Can you say like that? No, it is not possible. They are not visible. Then how they are existing? Yes, there are some invisible quantities. Those invisible quantities are traveling along with the visible quantities. Visible quantities means the terms that we are generating, like now we can measure voltage, we can measure current. At very first stage, people are not knowing these effects. Like when I am passing to transmission line like this, simple example I will give you. We all have Bluetooth headset, right? I hope Bluetooth headset. Now when we are connecting Bluetooth headset with your mobile, you do one thing. At the same time, keep one more mobile or your friend's mobile, connect hotspot. நீங்கள் ஹாட்ஸ்பாட் கனெக்ட் பண்ணிவிட்டு ப்ளூடூத்தை ஆன் பண்ணிங்க அப்படின்னா you will get that signal interference. See, I am sitting somewhere and my friend is sitting somewhere. I am having my mobile and I am connecting through hotspot. I am just turn on Wi-Fi and connecting my friend mobile Wi-Fi with that is internet with my mobile. Now at the same time your Bluetooth of your mobile is connected with what? Wireless, right? இப்போ இதில் கனெக்ட் பண்ணிட்டு இருக்கும்போது என்ன ஆகும்? There is some kind of magnetic waves is going here in between mobile and your Bluetooth. At the same time, there is your friend is also sitting near you, and in between those two phones, some kind of magnetic waves are going. Energy transfer, right? That is called internet. We are using some kind of net, that is signals. So now there are two different signals. When they are traveling close to each other, what will happen? Automatically, you will face that interference. I don't know how many of you are old students here. Many of you know that at very first when we have started the classes, at that time, earlier stage, I was used to having a Bluetooth headset when I am communicating with you all. But we all have continuously faced that issue. What is that issue? That issue is what? Signal interference. Because of the signal interference, at sometimes audio quality might not be good and the video will be stuck. So finally what we have understood, some visible quantities are there in our system, some invisible quantities also will exist when the moment we are passing voltage and current. So that is what people finally understood. So understanding the voltage and the current is very much important, and beyond that, understanding this invisible quantities properties also very, very important, because if they are not disturbing our system, then we don't need to worry about them. But they are disturbing. When I am taking electrical machines, I have some rotor and I kept some coil. Again I have some stator, I kept some coil. In between stator and rotor in electrical machines, it might be generator or motor, do you have any direct connection between them? Like rotor is there, on the rotor we may have some copper coil. Stator is there, on the stator also we have some copper coil. When we are starting the motor, I hope many of you observed the internal structure of the motor, there motor or machine whatever. So in between stator and rotor we don't have what? Direct connection. It means there is a gap. In between that gap, energy is being transmitted. When I am switch on the fan is rotating, mechanical power is being that is fan is started spending some mechanical energy. But where is it getting that energy? Actually it is getting that energy from the supply. Supply is electrical energy. In between supply and that is electrical energy and the mechanical rotation, there is a person, mediator, is called magnetic energy. So again people understood, yes, so in between electrical and mechanical domain there is one more domain. That domain is invisible to us, but knowingly it is helping us. Yes or no? Electrical entire world, like in our transmission line, some flux lines will exist. That property we will model as an inductor. Like in our inductance, like in our generator, induction motor, wherever we go, people started observing some invisible property. So that invisible properties is helping us at some places, it's disturbing at some places, it's based on the position. Like in our transmission line, we all have heard about a term is called magnetic interference. Why it is? What do you mean by magnetic interference? When two different transmission lines are going close to each other, what will happen? Automatically the magnetic lines produced by those two lines are getting what? Interfere each other, because they are having two different messages. If you are letting them to collapse, or if you are letting them to go close to each other, what will happen? Automatically the disturbance will fall in place. So finally what is the thing that we have understood? We have to measure the effect of flux produced by this coil. There are two transmission line. Now I have to measure, when I am passing the current, certain amount of current through this coil, how much amount of flux is being produced and what is the total distance covered by the flux, such that when I am need to, right, I have to carry one more transmission line nearer to this line. But what I have to do, I have to maintain a proper distance between them, such that I can avoid what? Magnetic interference. Yes or no? Am I correct? And there are some other kind of things also there, like you might have heard about these things. Bundling conductors will be there in our transmission line, and we will remodel the location of the transmission line. We might have gone through all these things in power system. So finally, one thing I would like to conclude here, apart from our electrical terms, apart from our mechanical terms, there are some other terms beautifully, knowingly will exist, and it is invisible in our system. But without those system, that is without those invisible quantities, we cannot design our system. That's all. Finally what people understood, yes, there are some kind of invisible quantity. Now we need to understand, we have to analyze the properties. But the thing is, you have to understand one more reality here. In any subject, if you go through it, in our in engineering syllabus, it might be breaked like this: circuit theory, electromagnetic field, power system, power electronics. But In after understanding all those things, you will also come to know. That's what I understood after reading all these things, after understanding all the basics. I finally came to know there is no difference between this subject and this subject, this. For our understanding, see, we cannot study this much books in 6 months, so they will be break it like that. Is in our semester it has been breaked, and some part of syllabus is considered as circuit theory like this. They have predefined, right? And we have started following that all things. But what my conclusion is, finally, don't think this subject is separate from this one like this. Finally understand what is the relation between all these subjects, why we are studying this one, what is the relation between this one and this one. That is the way you have to study. Okay, let me start. So finally we are entering into electromagnetic field theory. So understanding electromagnetic field theory is very much important now. Yes, very important. And the next thing is, what is the relation between circuit theory and magnetic theory? There is no big difference. The thing is, here you might have studied about current. Now what I am going to do now, while passing the current, I told you, right, when a transmission line, while passing the current, if I'll bring one more transmission line nearer to the existing one, there is some kind of disturbance is going on. That message is getting collapsed. How we are predicting that message collapses? It is very simple. While communicating with our friends, at sometimes unknowingly some other interference will come. Some other person will be talking with some other person. Automatically that speeches will be counterfeit. That is, will interfere the existing signal, that the communication signal between us. So that is called what? Interference. That's all. There are no more things. So we have to understand that one, and then we have to understand the beauty of magnetic flux lines, how it will exist, how it will travel, how we are experiencing. Don't think too much, because it is never visible. We are not going to see anything, but I am going to see. This is called magnetic lines. Just the way we are assuming like that. We understood like, okay, if I am bringing a magnet to nearer to another magnet, there is some kind of repulsion or some kind of attraction. Yes, in between there are some lines. That lines will be, we have to represent it in some way. That is simply called flux lines. So whatever the things that I am projecting on the board, don't think that they are called what? Actual representation. In this universe, nobody knows the actual representation of flux pattern. That is the way we experience, right? Based on our experience, we are going to project it. That's all. So the thing is, simply you have to understand, okay, this thing, it means what, it means what, it means what. That's all. Clearly understand. Okay, fine. In electromagnetic theory, we are going to define, there are two type of field. Electromagnetic field means there are two type of field. One, we are going to, that is, first we are going to discuss about static field. Second, we are going to discuss about time varying field. What is the difference between static and time varying? Can you please guess it? You just think about it. We know the difference. What is the meaning of static? What is the meaning of time varying? If a person does not vary with respect to time, then the element is called a static element. What do you mean by static? For an example, I am having a memory card. That memory card, every day, in that memory card I have stored some, what I can say, some movies like Friends, some movies I have stored it, right? Now, first day at 9 o'clock I am watching that movie. Right, I am just go to the external card, and I am going inside and I am clicking the movie button, and there is a term is called I, and I am clicking it and I am watching the movie. Second day at 1 o'clock I would like to watch the same movie from the same place. Is there any variation? Yesterday at 9 o'clock we have watched that movie. Again we are watching tomorrow, day before, that is yesterday. Tomorrow I am going to watch the same movie at 1 o'clock. Now in that memory card, yesterday and today, is there any changes in that information? No, that information is always constant. It does not vary with respect to time. That is the meaning of static. If a quantity does not vary with respect to time, it is always constant, then that is called what? Static. Then what do you mean by time varying? Time varying means if a person property behavior is keep on changing, then that is called time varying. See, for an example, this is the first day you are learning electromagnetic theory. Till now you have not learned a single word about, right? You don't know anything about electromagnetic field theory. Now what will happen? You are going to attend the classes continuously. After some 10 days or 15 days, at least you will come to know what is electromagnetic field theory. Yes or no? So your brain or your memory or something is varying with respect to time or not. If I will raise the question now, you may not be able to give answer correctly, but after 10 days definitely you will give some answer. So this is called electromagnetic field theory. That is what I have understood between static and time varying. So what is the meaning of that? Our brain is keep on observing, and it is started learning something. After a particular time period, there will be some changes in our brain. That is called what? Time varying quantity. That's all. So in the same thing we have to apply in our electromagnetic field. So fields are classified into two types. One is called static, another one is called time varying. So first thing, let us enter into the static field, because our main attention with static. Because in our applications at most of the places we are going to use this static field, because I don't want to let the flux to vary. Why? Flux has to be constant. In our transformer, what is the transformer is also called the constant flux device, right? I hope I am correct. Why we are maintaining like that? See, I am not going to deal anything with the magnetic flux, but magnetic flux is the heart of our power system, heart of our electrical system. Anywhere without magnetic field I am not doing anything. But the thing is, what I am telling here, separately just by generating magnetic flux I am not going to do anything, but I have some electrical quantity. In order to play with the other ties, mechanical systems, I need a domain. That domain is called a magnetic quantity. So the magnetic domain. So what is the purpose of magnetic domain? Simply it has to transfer the energy between electrical to mechanical. Under that time period, if that magnetic domain property is varying with respect to time period, then what will happen? Automatically it will disturb the electrical system or mechanical system. Of course both will be disturbed when magnetic field alone started varying with respect to time period. So maintaining this field as static is very important at many places. I am not saying that always we are going to use static, but our majority application depends on static field. Okay, so our main focus, we are in basics, right? In our engineering, that is in PG, we are sorry, UG, we are learning only basics, right? What do you mean by EMT? What is the definition? How flux will exist? We are not going to do any research here. Just we are going to understand what do you mean by static, what do you mean by time varying. That's all. So under static, once again, so first I kept electromagnetic field theory. It will be classified into two types. What are those? One is called static, another one is called time varying. Again we will take static field. In static, again we have two things. What are those? There are two things. One is electrostatic and another one is called magnetostatic. I told you, right? So what I told you, while passing the current, there is some kind of person is existing around the conductor. Okay. Now the thing is, without understanding the property of current, can you directly deal with the magnetic flux? No. First I have to know how much amount of current is entering into the conductor and in which direction it is entering. And then I have to find in which direction that flux is revolving around the conductor when I am passing the current from right to left or left to right. Everything we have to understand, right? That is the basics, right? So understanding the properties of charge, electric current, voltage, potential energy, work done, everything we are going to deal in electrostatic, such that we will get the final, that is we will get the conclusion between the charges inside the conductor, what will happen in terms of electrical terms. Electrical means what? I already defined, voltage, current, charge, like this. Then I have to, once I will get the clear idea about it, then directly we will relate these things with the what? Magnetic domain. That is called what? Magnetostatic. Yes or no? Exactly. So in electrostatic, usually we are dealing with the Coulomb's law. That is the first law that we are going to discuss in electrostatic. And then you all might have heard about, there is a law is called the Gauss law. What is the relation between this Coulomb's law and the Gauss law? That things we will deal with later, but I am just giving introduction. In electrostatic, in order to understand the properties of charge, current, voltage, I am going to travel along with the Coulomb's law and the Gauss law. Again, I am going to take magnetic domain. That is called what? Magnetostatic. In magnetostatic, here I am dealing with the Coulomb's law. There I am going to deal with the Biot-Savart law. Here I am dealing with the Gauss law. There I am going to deal with the Ampere's law. So there is no difference between this and this. Directly we can interrelate them. Here we are keeping what? Electrical people. Here we are going to keep what? Magnetic people. Finally what we are going to understand, there is no difference between them. There is a kind of link will be there. Because without current, flux won't be exist. Whenever there is an experience, if you experience flux, there is a chance of getting voltage and current. So by default, there is a constant relation between these two domains. That things we will understand at last, at the end of the electromagnetic field. Okay. So now finally what we have understood, electromagnetic field theory is not a separate subject. We left something in our power system, that invisible quantities, but later we understood without that invisible quantities we cannot do anything here. At some places it is helping us, at some places it is disturbing us. At which places we are getting that disturbance, how much effect is there, at which places we are going to utilize it, how much effect it will be there, how much effect we are, that is how much amount of energy that we are going to transform with that invisible quantities. Everything we have to understand properly, such that you will be able to travel along with the entire system happily. Now once you understand electromagnetic theory, then the entire system will become what? Like this dot. Then you will get the complete meaning of why I have studied circuit theory. and then how I am designing the electrical model in power system, how I am generating the power, how our motor is working, how our power electronic drives are working there, how we are utilizing it, how everything you will understand finally, right? Because you know everything, like current, you know, flux also we know, what is the effect, everything you know, right? Yes. So finally what we have understood, electrostatic, magnetostatic, there are two domains. First what we are going to learn, we are going to start from electrostatic. As I told you, in electrostatic what we are going to learn, we are going to learn the basics of Coulomb's law. Again we are going to learn Gauss law. Once it is over, electromagnetic field theory is over, then I will bring the relation between this one and that one. Nothing is there. After that you will be able to crack all questions. See, don't just love this subject, you will enjoy it, right? Fine. And apart from that, we have to learn some basics, that is called boundary conditions are there, and the capacitance effect will be there, inductance effect will be there. I will teach you all those things one by one, but you need to be patient, right? Fine. Then I had been discussed about a time varying field also, right? In time varying field what we are going to do, in time varying field we need to learn about some basics. What are those? I hope all of you heard about a law is called Faraday's law. In Faraday's law, we are going to deal with the quantities which are varying with respect to time period. At some places it will be there. I told you, electrostatic is not the only thing, that is a static field is not the only thing that we are going to apply at all places. At some places we are also going to apply what? Time varying field, right? So we have to discuss about Faraday's law under time varying field, right? And then we have to discuss about Ampere law. Already we had been discussed, right? But in Ampere law there are some inconsistency, right? That inconsistency of Ampere law will falls under time varying field. That things you will see later. That's all. Okay. So these are all our entire syllabus of electromagnetic field theory. But before that, let me go from the ground level, basics. We will start from basics. I will approach level by level. We will see our, that is, we will get the progress such that you will get the complete picture of electromagnetic field theory. Okay. Now keep the heading basics of electromagnetic field theory. That is the topic that we are going to deal now, right? Fine. So in basics, what we are going to learn, first thing is, let us start from the first quantity in basics, that is called scalar. After a long time I am touching marker. Understand my handwriting, I don't know how my handwriting will look like. You just adjust it. 1 or 2 days I will get the catch. I will catch it. Okay, first scalar quantity. In basics of electromagnetic field theory, first we are going to deal with the scalar quantity. Now what do we mean by scalar? There are two type of quantities, right? One is called scalar and another one is called vector quantities. Now you please tell me, what do you mean by scalar quantity? Every one of you say, right? What do you say? Says scalar. What is the definition of scalar? It has only magnitude. Okay. Let me ask you something. I am having a certain person is called A and its value is 10. Now I am just asking you whether it is scalar or not. Of course, sir, it is scalar. It is scalar, right? Only two quantities are there, vector quantities, scalar quantities. Of course, already we dealt all these things in what? Circuit theory. Every one of you knows the basics, right? In mathematics itself, you learn these things. I will just recollect it once, because let me teach you something new. I know some of you not know some basics are there in scalar and vector. Let me teach you, right? That's why I am traveling from the basics. Yes, A is called what? Sir, 10 is a constant number, right? 10 is a number. Is there anything apart from that? No, number is number only. There is no direction for that. Yes. So if something has only magnitude, then there is called a scalar. Yes, you are correct. Now let me keep something here. A is equal to x plus y. Now my question is, once again I am asking you, is it scalar or not? Is it scalar or vector? The second thing that I kept it here is scalar or vector. Can any one of you guess this one? You just think, what is this? Let me tell you the answer. This is also scalar only. How, sir? Now you please tell me, what is the direction of this one? In which direction this vector is traveling? No, it has some values. The vector A, the person A is depending on two independent variables. That's all. One is x and another one is y. There is no specific direction for this. There, for an example, if I keep, see, the thing is, here your A is a constant. You have to understand the difference between this. A is a constant, but here A is a function. What is the difference between? Function means this person is depending on some independent variable x and y. When I am keeping, for an example, if I am the controller and I am keeping the value of x as 2 comma 3, then what will happen? Automatically the value of a is going to be x is replace x by 2, y by 3, 2 plus 3 will become 5. Is it constant? Of course this 5 is constant, but a is not constant. Why, sir? At sometimes now it might be 5. Suppose if I'll keep the value of x comma y has some other value, let me keep 3 comma 9. Can anyone guess what is the value of a? A is what? X plus y, whereas the value of x is 3. What is the value of y? 9. 9 plus 3? 12. Yes, exactly. We are going to get 12. So what is the conclusion here? Now you please tell me, is it scalar or vector? It is what? It is scalar. It is not having any direction. Just it has what? A term is called 5. It has what? A term is called 12. So what is the conclusion? Scalar. Now rewrite the definition of scalar. What? Scalar is a function. It is not a constant. That is what we have understood now. Are you guys agree with me? Scalar is not always constant. Yes, of course it is constant, but in back of this it is depending on someone. At some places we might deal with some constant value. Of course I am agree with that, but it is not always true. Functions are also considered as a scalar only. So what is the conclusion? Scalar is a function and it has only magnitude. That's all. It has only magnitude. It won't have any direction. Scalar is not a constant. Scalar is a function. There is a difference between constant and a function. Constant will exist from the function. So what is the origin? Origin is a function. It is not always constant. That is what I would like to conclude. So scalar is what? Scalar is a function. It has only magnitude. There is no specific direction for the quantity. That's all. That is the basic definition of scalar. Am I correct? Of course I'm correct, right? Now let me ask you some questions. Let us consider voltage V is equal to 20 voltage. Okay, V is equal to 20 voltage. Is it scalar or not? Of course it has some 20 voltage, that's all, right? Yes, it is a scalar quantity. Are you guys agree with me? Yes. Let me define current. Slowly observe. Let me define current. Current I is equal to, let me consider as 10 ampere. Is it scalar quantity? Yes. Let me ask you some questions here. Many people are having a small doubt here about current. That is one of the famous interview question, right? One of my friend has faced this interview question, right? Let me ask you. The doubt is, actually interviewer asked whether the current is a vector quantity or a scalar quantity. That is the question. Now you all please tell me the answer. Whether current is a vector quantity or a scalar quantity. You might have gone through this current at many places, of course at entire places, except in control system you might have seen the layout, you may not go through this current, but in rest of all subjects definitely the term is there in every subject. You please define. In digital electronics you may not find, but other places. You please tell me whether the current is vector or scalar. Now anyway, let me tell you the answer. The answer is scalar. How will you define? Now there are two ways to define, but I told you, you have to understand all things from the basics. Once you understand the subject, then you will get the another definition. Let me simply teach you. We all know I can be defined as what? Basically. How will you define? What is the basic representation of your current? It will be in general in network, that is in our circuit theory. Basically current is defined as what? dq by dt. Are you guys agree with me? You have to agree. Now q is what? Q means charge. Yes. T means what? Time. Are you guys agree with me? Yes. T is called time. Q is called charge. Now my question is whether the charge is scalar quantity or not. Sir, charge is scalar. Very simple. You can say 10 coulomb, 20 coulomb, 30 coulomb, 40 coulomb in a conductor. Simply we can define, right? Anything, not only in conductor. So charge is what? It's a scalar quantity. It has some value, that's all. Right? What is the conclusion? Charge is a scalar quantity. Time, sir? 1 o'clock, 2 o'clock, 3 o'clock, 3 o'clock. Just it is an integer. Do you have any direction for that? It's a scalar quantity. 5 o'clock, it's a scalar quantity. 5.3, 5:30, it's a scalar quantity. Have you heard about like thing? If I will ask you time, what is time now? Sir, time is 1 o'clock at 30 degree. Can you say like that? Anywhere? No. Time is what? Time is time. it don't have any direction. Specifically we have to say, sir, it is 1 o'clock, it is 2 o'clock, it is 3 o'clock, 4 o'clock. What is the conclusion? Time is a scalar quantity. It does not vary with respect to the direction. It is automatically what? What is the present time? At this instant, what is the time? You have to see the clock, sir, it is 6:30. That's all, right? So what is the conclusion here? Time is a scalar quantity. So current is defined as dq by dt. If charge is scalar, time also scalar, then what about current? Sir, current is depending on 2%. That those 2% are always scalar. Then how your current will become a vector quantity? Current also being a scalar quantity. I hope you guys are getting me. See, in interview, you simply explain in this way. They won't ask you, is there any other way to define? They won't ask you like this. They will test whether you know the basics or not. That's all, right? So simply define. I know current equal to this one, so it will be defined like this. And we all know charge is what? Scalar quantity. Time is what? Scalar quantity. Current is depending on these 2%. By default, current also will become a scalar quantity. So finally, what we have understood? Voltage, it is predefined. It is always scalar. It has some magnitude at all places. Similarly, current is a scalar quantity. Charge is a scalar quantity. Time is a scalar quantity. Next, let me define one more person. That is one more interview question. Temperature. Whether the temperature is a C, don't think that these questions will exist only in interview. You know, basically, in your exams, they will test you like this. Temperature is here. They will define like this. Vector, scalar, sometimes vector, sometimes scalar, none of the above. They will define the options like this. But you have to understand the basics. Without knowing the basics, you cannot go in depth, right? Fine. You please tell me whether the temperature is a scalar quantity or vector quantity. Can you tell me the answer? Okay, anyway, let me define. Temperature is what? It's a scalar quantity. I hope class is going good. I'm watching my class. If you find any interference, you please let me know, right? Fine. So temperature is what? 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius. Sir, what is the body temperature? 25 degrees Celsius. After some time, 30 degrees Celsius. That's all. Just we will define the what? Magnitude. We won't have any specific direction like 30 degree Celsius at an angle of 20 degree. It is placed at 20 degree. Can you define like that? No. We will simply define what? Temperature of the body is what? Temperature of the metal, temperature of the finger, temperature of the marker, temperature of the board. Simply temperature is a scalar quantity. So temperature also considered as a scalar quantity. Next, area. You will define area. See, at some places area will be defined with okay, let me define about area later, because I have to conclude something about area. I don't want to directly specify. Let me consider volume first, because with the area I have to do something. Later I will define. So let us consider volume. Every one of us knows volume is what? Volume is a scalar quantity, right? Next, I'm going to talk about a beautiful person, right? That is called mass. Mass is what? Mass is a scalar quantity, right? So it is constant at all places. Mass is always constant. But my question is, weight. What is the difference between mass and weight? I am just asking you. Okay, I think I am writing somewhere like this, right, without having order, because it is basics. Later I will follow the order. You please make a note step by step. Temperature is over. Next, now I am dealing with the what? Mass and the weight. You please tell me temperature and volume, and then discuss about the difference between mass and weight. See, mass is a scalar quantity. How? You please do it by yourself, because I had given many things, right? Now go and make a research. What is mass? Don't unnecessarily waste your time. In free time, do it. Okay, in your preparation time, don't spend unnecessarily on it. Okay, fine. Mass is a scalar quantity, sir. What about weight? Weight. Make a research on it. Weight is, it will be changed with respect to the place. Suppose I am in Earth. What is the weight of a person? Now go to the moon. You can just search it on Google. What is the weight of a person when I am in moon? If in Earth, if it will be considered as 20 kilogram, in moon what will be the weight? In Mars what will be the weight? You can just make a research on it. Finally, you will come to know whether this person is a vector quantity or a scalar quantity. So that's your task. Anyway, mass is scalar. I am defining it already. You have to find the difference between these two, and then finally guess whether the vector has some specific direction or not. Sorry, weight has some specific direction or not. Answer is vector. Anyway, you can deal later. After making the research, you please keep the answer. Okay. So this is all about scalar quantity. I hope you are getting me. And I would like to ask you, how will you represent the scalar quantity? Guys, I am watching you. If you have any problem, please let me know immediately. Okay. I don't know whether the signal is good or not, because I am taking the class after a long time. Fine. Next, so scalar is over, right? Immediately what we need to discuss? We need to discuss about a term is called vector, right? Yes. Now you all please tell me what is the definition of vector. I hope you will tell you like this: vector is the one which has both magnitude and direction, sir. Yes. But now I am conclude one more thing. I would like to conclude one more thing. Yes, your definition is 98% correct. But in addition, you have to insert one more word with this. What is that? How many of you know that one? Vector is not only simply considering, okay sir, it is the vector quantity, it has only magnitude and a direction. If I will find anything, directly I can define this is vector. You cannot say like this. Then how to define? Let me conclude. I know when I was discussing about the current, I told you for the definition, right? In the definition point of view, to define whether the current is vector quantity or scalar quantity, there is an alternative way. But I didn't discuss it. That is not required here. But let me conclude one thing. You all have heard about current in our electrical circuits. Right, in DC, current might be constant. When you are entering into AC, that's the point where you all will get the doubt. Sir, current is a vector quantity. Here I am facing some issues. You might be thinking like that, right? That's what I am telling here. So you cannot define like this directly. While traveling along with the current also, there are some, that's what I am telling. For the vector, it is not the definition. If the current, if a person is having one magnitude and direction, then that person is called a vector only. But with that, what I told you, we have to insert a word is called, that function has to satisfy the property of vector addition. Okay, just insert that word with your vector term, right? So finally, what is the definition? Vector, it has what? It has some specific magnitude and a direction. Okay, vector is the one which has satisfies both, right? Which has both magnitude and a direction. With this what? And also it has to satisfy the property of what? Vector addition. That's all, right? So vector is what? Vector is the one which has both magnitude and direction, and it also has to satisfy the property of vector addition. That's all. That is the complete definition of vector. I don't know how many of you know this one, right? But from this moment onwards, you have to follow this definition at all places. At some places you might be see ஒரு சில குவாண்டிட்டியை பார்த்தோன்னே அது பார்க்கறதுக்கு வெக்டர் மாதிரியே டிஃபைன் பண்ணியிருப்பாங்க. And you just நீங்க பார்த்தோன்னே சார் that is vector. I know. From the basics I have learned very well. I know sir that is vector. But you don't know vector addition. Whether it is satisfies, whether that given quantity satisfies vector addition or not. You should keep your attention with that. You have to check whether it is satisfies or not. Yes, it is satisfies, then you can travel along with it. Directly, just by looking at the quantity itself, you cannot define like that. Okay? Yes. So that is the basic definition of vector. Right now, let us see some example for vector. I am just asking you, first example is force. Force has what? Specific direction and has some magnitude, right? That is called what? Force. I'm pushing you, right? For an example, when we are lifting some weight, or when we are throwing some balls, something, right? All are what? Having a specific இப்போ நம்ம பால் கிரிக்கெட் ஆடும்போது பால் எப்படி போடுவாங்க? It has some specific direction, right? நம்ம ஒரு specific directionல தான பவுல் பண்ணுவீங்க, right? So we are rotating and then we are going to throw like this. So the thing is what? There is some specific direction. It has some it will going to follow some certain angle continuously, certain direction continuously, right? With some certain magnitude of force, right? That's all. So force means what? Yes, of course it's a vector quantity. Like you can consider force, torque, both are what? Analogous to each other. See, simply we can bring, what is the difference between force and torque? There is a term is called translational system and rotational system in control system. Have you heard about it? Mathematical modeling of control system. I don't know how many of you got through. I have gone through this. You please go through it, right? So that is the basics. How to define a mathematical, that is mechanical systems in terms of differential equation. There we might have the relation between control system. Starting la nama idha padichirupom illaya, voltage current analogy, force torque analogy, force voltage analogy, force current analogy. What is this? What is the difference? What is the relation between force and torque? That's what I am telling. There is no difference between this subject and that subject. Okay, come to the conclusion. What is the difference between force and torque? Nothing, sir. Force is a translational system. Force, it's a kind of function will exist with a translational system, that is moving system. Like I am shifting from here to there. I'm a translation system. Suppose I'm taking my hand, right, and I'm rotating like this. What is this? Sir, this is a rotational system. It is keep on rotating. So there is a kind of torque I'm applying to rotate it, right? So by myself, our nature had given some power to me. So I'm just giving that power through my nervous, and automatically that force is it's creating some kind of torque here. Suppose I'm stopping and I'm having some object here, I'm pushing like this. What is this? So here I'm applying force, here I'm applying torque. That's all. This is rotational system, this is translation system. So anyway, what is the conclusion? What are the things that we had been discussed about the force, same thing you can observe in our torque also, but the kind of difference is it is rotating, it is shifting from one point to another point. So anyway, both are vector quantity. That's all. Next we will learn something about like displacement, velocity and acceleration. I hope class is going good. You can write all those things first. Dipole moment, we will define about this person later, because now I cannot spend that much time. Dipole moment, and then you can consider velocity, you can consider displacement. All these people are considered as vector quantity, right? You can also consider acceleration. All are vector quantities, right? Fine. Now how will you represent a scalar quantity and how will you represent a vector quantity? See, very simple. I have to show the difference, right? Then only we can define the basics. Like we can travel along with this subject. I have two person here. Both are AA. Both are called AA only. But in the nameplate, they kept a scalar here. In the nameplate, they kept a vector here. But you are looking inside. Both are look like same. But then how to differentiate it? I have to show the difference between scalar and vector. Suppose if it is not there in the nameplate, if name is not there, then how will you come to know whether these two persons are scalar or vector? As a designer, I know what is called scalar quantity, what is called vector quantity. When I am giving it to you, you are going to purchase these things from me after design. Then what will happen? You will come to know but just by looking at this self. Suppose you are a faculty, I am working in some construction company. You bought something from me to show the things to the students. I forget these two things to write. Just I have written the functions. Now it is in the nameplate. When you are showing it to the students, what will happen? Whether the students will find the difference between these two. That is the first time they are looking at things. How they come to know whether this, yes sir, this is called a vector, this is called a scalar. Did they guess? No, they won't guess, because we all know, right? Common sense. Sir, both are called the same quantity. You will define like that. Now what I have to do? I have to show the difference, right? Yes, I know scalar is a function. Scalar is a function, not a constant. Scalar is a function which has what? Only magnitude. Yes, just A means some 10, 20, 30, 40 or x plus y, x square plus y, x cube plus y cube plus z cube, something. But vector has some magnitude and also having a specific direction. That direction might be like this, or you might go like this, or you might go like this, or you might go backward. Yes, it has some specific direction. That direction has been represented by like this. Am I correct? Now you can show the difference. Sir, it's a scalar quantity. It's a vector quantity. It has some specific magnitude and also it has some direction. Am I correct? Yes. So that is the basic representation. In place of A, you can keep anything that you want. You can keep V, I, P, Q, R, S, whatever the terms that you want, you can keep it here. That's all. So that is simply called what? Vector quantity. Next we are going to travel along with the unit vector. Keep that thing. Next we are going to discuss about unit vectors. Okay. Every one of us knows the meaning of scalar. Now we know the meaning of vector. Yes, of course. Now you please tell me, we might have studied about the term is called unit vector. Of course, even in our engineering curriculum also, there are many questions are there. They will ask you, find the unit vector of this given vector functions, find the unit vector. At many places you might have gone through this term. How many of you know the purpose of this unit vector? Just think and apply it. Unit vector. What is the purpose of unit vector? I told you, right? What I told you? Sir, it is called a scalar. Yes. It is called a vector, of course. Scalar something, I can say a 10, 20, 30. Okay, sir, we can simply define. When I am talking about vector, I have to write like this: 10 at an angle of 0 degree, 10 at an angle of 20 degree, 10 at an angle of, for an example, this is length of my hand. Let us consider 1 to some 7 or 8 centimeter, like initially at 0 degree, and then some 20 degree, right? And then some 30 degree or 45 degree, right? Yes, it is 45, right? And then 60, 70, almost it will become what? 90 degree. But is there any changes in the magnitude? No, it is fixed, but it's keep on changing its direction. So each and every time I have to define like this: 10 at an angle of 0, 10, 20 degree, 30 degree, 10 at an angle of 45 degree, 10 at an angle of 60 degree, 10 at an angle of 75, 10 at an angle of 90 degree. Yes sir, exactly, that is correct. So what is this? This is called vector. Okay, that is correct. Each and every time I am talking about what? Direction also. In which direction that vector is lies. Yes, now it lies in x direction, then it lies in y direction, it lies in between x and y, it lies somewhere. So what is the conclusion? We have to specify its direction properly while traveling along with the vector. Now finally the conclusion is unit vector is the one which is helping us to find the direction. It is not helping by itself, it will shows the direction. For an example, we all know how to represent 3 coordinate system, right? Let me define simply. 3 coordinates means what? It has 3 axes, that's all, don't think too much. 3 coordinates means it has 3 axes. Now I would like to define, there are 3 coordinates. Yes, this is x coordinate, and this is called y coordinate, this is called z coordinate. Now I would like to keep certain vector on x axis. Then what will be the representation? Listen, if a person, this is x vector, right? In order to show its direction, let me keep one more arrow mark and I will keep ax. So A is called what? Unit normal along with the x-axis. A is called what? This is called unit vector along with the x-axis. So it is the direction of the selected vector. Similarly, this is called y-axis. Yes, its correspondent unit vector is what? Its direction. Okay, y-axis is this one. This is y. Its direction is what? That will be represented by ay. That is called unit vector, right? Similarly, for z, how will you define? It will be defined as az, suffix z, right? Sorry, for za, its corresponding unit vector is a. It shows the direction of z. This a shows the direction of y. This a shows the direction of x. That's all. That is called simply what? That is called unit vector, right? I hope you guys are getting me, right? Slowly I will define, don't worry. Now, let me rub these things. I hope class is going good. If you find any difficulties, please let me know immediately. Sorry. Okay, sir, this is x and its correspondent is ax. Now the question is, how will you find out the value of this ay, this ax, this az? It's better to write here itself, then you'll get the clear idea. Let me write. Listen, I would like to know the value of ax. Actually, I have a vector is called x vector. Now the thing is, as per the definition of the vector what? It is the one which has both magnitude and direction. Later see that vector addition, always keep it in mind, because I cannot say always it is satisfies vector addition, vector is vector addition. Now you know the basic definition of vector, right? In that vector addition, I told you just to insert a word is called vector addition. In interview or while going somewhere, when we are dealing along with the vector functions, you just check it whether it satisfies this property or not. Here just to keep that word in your mind, right? So vector, basically you have to keep that magnitude direction, but don't forget to keep what? Vector addition in back. Okay, that's all. So vector means what? It has, this is x vector, it has its magnitude. Representation of magnitude is what? I hope you all know this one. This is mod means what? It represents the magnitude of the vector. That is the representation. And then what I had been told you, we are in vector quantity. It has magnitude as well as direction. Direction, how will you define for x? Its correspondent direction will be defined as ax. Are you guys agree with me? You have to agree with me. Similarly here, how will you define this one? There is a term is called what? Y vector. Yes sir. It has what? It has its own magnitude and its direction. Am I correct? Yes. Come to the z axis. Yes. There is a vector is called what? Z vector. This z vector has its own magnitude and its direction. Exactly, that is correct. So finally, from here, I would like to know the value of ax. Because I told you in your examination, at many time you will be tested to find out the unit vector, right? So let us see. So from this, if you will define ax, just you have to pass this magnitude to the left side, right? Am I correct? So ax equal to, for a specific x is a vector, for that x I am finding the unit vector such that will be equal to what? X vector upon mod x vector. Am I correct? Yes. This formula you might have got through. at all places. Similarly, here how will you define ay? Ay equal to, is this portion is visible to you all? Yes, that is visible. Fine. So ay is equal to what? Y vector upon mod of y. Exactly. Similarly, let us consider z vector. Az, which is equal to z vector upon mod of z vector. I hope you are getting me. What is the meaning of what? Unit vectors, right? So what is the meaning of unit vector? Unit vector simply gives the direction of the selected vector, that's all. Getting me? Selected vector is y. Its correspondent direction will be represented by ay. Selected quantity is z. Its correspondent representation direction is what? A is z. That's all. So unit vector simply gives the direction of the selected vector. That's all. There are no more things, right? So simply understand. That's enough. I hope you are getting me. There are no more things to discuss about unit vector. Just remember this term. Slowly I will enter into the subject. You will get the clear idea, right? We are in the basics. Okay. Let us discuss about vector addition. Keep that in. Next we are going to discuss about vector addition. Now, in order to add two vector quantities, usually we are following two rules, right? Usually we are following two rules. Guys, any problem? If you have any problem, please let me know. So there are two rules. One is parallelogram law. That is the first law we are going to define. And second one is a triangular law, right? Anyway, just to understand parallelogram itself, you'll get the clear idea. Let me teach you how to add two vectors, right? Yes. So first of all, vector addition. For an example, a vector is defined like this. Let me take two vectors here. One is z vector, and I will consider one more vector here, that is called y vector, right? See, don't make notes. So just observe first. Later you can add. Let me keep something somewhere like this, such that you will get the clear idea, right? So this is, let me consider x also, no problem. So this is x vector, right? This is x vector and this is y vector, right? Now, what do you mean by parallelogram law? That's very simple. Listen. Sir, this is x vector and this is y vector. See, there is no difference between vector addition, vector subtraction. You all have to understand. In some books also, even I too, when I was studying these things at very basics, I would like to differentiate like this. This is called a vector addition, this is called a vector subtraction. Later I understood there is no difference between them. Simply we have to see the logic behind of that, right? Let me explain. So this is parallelogram means parallelogram. It will be defined as parallelogram. So the basic definition, that word, its meaning is opposite sides are having equal length. What do we mean? Parallelogram means this is a line is called y vector. What is the parallel line for this y vector? Parallel means you have to take in the same distance. Let me take one more line. Parallel to this, I have to take one more line. Just to keep it in the opposite side. Opposite side means for this, opposite is this one, right? So from this, you have to keep it in the opposite side with the same length. So let me keep it somewhere here, right? Similarly, this is x vector, right? Similarly, take this one with the same length, just to keep it, place it in the opposite side. That's all. Now we get the complete diagram, right? Where we have started, this is the origin. From this origin, we have defined these two vectors, and then these two vectors are going like this. Yes, finally they are joining here. So just draw a dotted line, attach this point, then you can complete it. Yes, this is. Now let me make a dotted line here, because our target is not this one. Our target is achieving this one. So finally, this is what? This is called x vector plus y vector in the same direction I have done. Defined is what? Y, and its corresponding direction is defined. X and its corresponding direction is defined. So whatever the direction I kept it here, same direction. In the same direction I kept this vector. This is the direction of the x vector, same direction. This is the direction of the y vector, same direction. So they are joining somewhere here, and I am attaching from the origin, that is going to be resultant vector. You can define it as z vector. Something, I am just putting some name, don't think too much. So that is called what? Parallelogram. That is how we are adding two vectors. I hope you are getting me. Now coming back, then what do you mean by vector subtraction? I have just thinking about it. Do I need to define it separately? No. Then what do you mean by vector subtraction? That is not vector subtraction. The thing is, suppose this is y direction, y vector. Suppose if you want to represent minus y vector, can anyone please guess it where it will be placed? Y vector, this is y vector and we know its length. I would like to consider the same length but with the minus. What is the difference between plus and minus? The difference is they are 180 degree opposing each other. See, very simple. What is the difference between plus and minus? Plus will attract each other. We will add. If I have 2 plus 3, what is the meaning? 2 plus 3 will become 5. If I have 2 minus 3, then we will do subtraction. It means what? Why we are subtracting? They are traveling in the opposite direction. They are not traveling in the same direction. That is the meaning of what I can say. That's why in x-axis there are 2 coordinates. In the first quadrant, x values are positive, whereas in the opposite side, values are negative. It means what? There are 2 vectors. They are traveling in the opposite direction. Right? One vector is traveling like this. Another one vector is what? Traveling like this. It will become what? X-axis, but what? 2 different values. This is positive, this is negative. They are traveling in the opposite direction, right? So its meaning is what? This is y vector. Minus y vector means there are 2 vectors. One vector is I have to keep like this. Opposite I have to keep like this. So they are traveling like this, opposite, right? So then where is minus y vector now? Just to go to the opposite direction, place it here. Once again I am defining there is no difference between minus and plus. But you have to understand the logic behind of them. What is the meaning of minus? What is the meaning of plus? Fine. Now we know minus y vector, right? So we have x vector, we have minus y vector. Let us start applying parallelogram. What is the meaning of parallelogram? Parallelogram means opposite sides are having equal length, right? So this is x vector, right? This is the direction. See there. I am just shifting. So take the same length in the same direction and just shift and place here. Getting me? Yes. Where we have to place? At the edge of y vector, right? Yes. So it will be placed somewhere here. 1 minute. I don't have touch for the last 40 days. Fine. So next, similarly, this is opposite side, right? We have to take the same vector and place it in here. That is, place this here, such that what I will get? 1 minute. Let me place it somewhere. Yes. Same length, right? So whatever the length that we are considering, same length will come from here to here. And then what you need to do? Okay, sir, this is going to be what? Y vector, and this is going to be what? X vector. Of course, this is minus y vector. Now just attach these 2 points. I told you this is not my requirement. My demand is what? What is the resultant vector? See, these things will apply at many places in our synchronous motion. Just to go through the concept of synchronous motion, where we are developing the phasor diagram. Without phasor diagram, you won't understand that magnetic power transformation, like reactive power compensation, when it is in leading power factor, when it is in lagging power factor. To understand the definitions, they are very, very important. I told you, I am repeating again and again. There is no difference between this subject and that subject. All are interrelated, but you have to study in a beautiful way with the proper interlogic, right? Fine. Let me continue. This is minus y vector, this is x vector. If I add these two, finally that attachment will give you x vector minus y vector. Some of you might be thinking like this, sir, why can't I consider minus y vector first and then plus x vector? You can consider, instead of writing like this, you can also write minus y vector plus x vector. Okay, there is no difference between that. These two, it will give you the same answer. So now the conclusion is what? Did I done any subtraction here? I didn't do any subtraction. I just found the place of minus y vector. Now, subtraction pannuma. What I have done? Minus y vector. Yes, this is y vector. Where is minus y vector? Yes, it's traveling in the opposite direction with the same length. I placed it. Just I have followed the rules once again. I applied the parallelogram. I got the resultant value. So this is simply called what? Vector addition. And I told you there is one more law is called a triangular law, and some people are calling it as tail to head rule. Some other things are there. You just understand. This is enough, right? Don't think too much. Anyway, simply I will teach you what do you mean by triangular law. I will just show you because I cannot leave that word here. Yes, we are crossing our time, I know. Just give me 1 more minute, I will complete. Okay, listen. A vector is defined like this. They are defining a certain vector. This is called x vector. And one more vector is defined like this. Simply, let me call this is y vector. So simply, triangular law. Just observe. This is one complete structure, right? So how will you make triangular here? This is a triangular has 3 sides, right? 2 sides already projected. Then the third side is simply going to be the addition of already existing 2 sides. That's all. That is triangular law. Simply if you add these two, you will get the answer. Third set will going to be simply follow what? Addition of these two. Now what we have done here, I kept two vectors, right? In parallelogram, I kept two vectors like this, right? Yes. Now, but the thing is what? In this case, I have direct attachment between the two vectors. But here, yes, of course, here we have the direct attachment like this. Now the thing is what? When I am adding these two vectors, I don't have the proper connection between the vector here. Right? See there, here we are starting here and they went to like this and then finally it will be directly attached. But these two vectors are traveling like this. In order to place them, in order to follow the vector direction, what I need to do? If I'll place this one here, you take the direction, take this direction, right? Place it in the opposite side. Such that what will happen? Yes, we are following, we can join these two. Are you getting me? This is the first vector. See there, edge of the first vector direction, I am placing the second vector. Finally, I am joining these 2 points. Origin. This is called head-tail rules. It is also called, right? That is next thing. But in parallelogram, where is this logic? In parallelogram, two vectors are being. That is, the vector direction will be here and here. Can I go like this directly and can I join these 2 points? No, sir. That is wrong. What I had been told you. See that this is the origin, right? You have to find the edge of this vector. You have to start from this vector edge. But here, see there, from the origin itself, these two people are traveling in the opposite direction. Then what I need to do? Take this one, find its opposite, attach it here, such that, see there, at the edge of this vector, I am starting with the next vector, such that this is ending point, you can join. Or otherwise, take this vector, keep it opposite side here. There are two ways. Either you can go with this one, or you can go with this one. Anyway, finally, you will get the answer. So this is parallelogram or that is what I've been told you. There is no difference. Either you can go up with any one rule. That's enough. Okay. So that is the difference between triangular rule and a parallelogram. Right. Now your target is you have to understand the properties of this vector addition. Okay. It's let me do those things in our next class. Right. So next thing is we have to understand the properties of vector addition. What do you mean by vector addition? I would like to go with some examples such that you will get the clear idea whether it is true or not, right? Fine. So with this, let's wind up the today class. If you have any problems with my communication, because I know some of you guys are new with the class, but anyway, already you are watching our videos in our YouTube, in our website, right? So I hope you are feeling comfortable. If you have any problem with my communication or with the explanation or with my speed, whatever the things that you are having, you please drop it in our group. Directly keep it in the, post it in the group, right? Such that I will be able to make corrections. Don't be hesitate to ask your queries, because that's my responsibility, such that if it is required, then I will change myself. If it is not required, then I will correct you, right? That's all. Let's wind up the today class with this. Thank you all.